Bismillahirrahmanirrahim. Dear students, we are going to start our new topic, that is the measurement of concentration of solution. And we have discussed in previous lecture about the percentage, and the second measurement of concentration of solution is molarity. So we are going to discuss about molarity. Okay. Molarity, the most common solution concentration measurement, is defined as follows. Remember, percentage is also solution concentration measurement, but molarity is very commonly used as solution concentration measurement. So molarity is represented by capital M, and the definition of molarity is number of moles of solute dissolved in 1 liter of solution, or 1 dm cube of solution. In your book, instead of liter, dm cube is mentioned, so don't be confused for that. Okay, so molarity is equals to number of solute per liter of solution, which means number of moles per liter of solution, or number of moles per dm cube of solution. Liter and dm cube both are same. Now basically, if there is one number of mole of any solute dissolved in 1 liter of solution, then its molarity would be 1 molar. Unit of molarity is 1 capital M, 1 molar. Okay. Similarly, if there are two number of moles of solute dissolved in 1 liter of solution, then its molarity would be 2 molar. Now you would understand in detail by considering this example, this problem, that what is the molarity of solution in which 50 gram of copper sulfate is dissolved in water to make a 2-liter solution. So what you have to do is to write the formula of molarity, because you have to calculate molarity. So the formula of molarity is moles of solute divided by liters of solution, or dm cube of solution. Now the step number 2 is we need to determine how many moles we have in 50 gram of copper sulfate, because we have in formula moles of solute, so we have to determine moles of solute first. You know the molar mass of copper sulfate from periodic table is 159.5 gram per mole. I have clear the calculation of molar mass from periodic table in your class. Now in the second step, you have to calculate the number of moles of copper sulfate. In first chapter, we have discussed in detail about the calculation of number of moles from any mass in gram and molar mass of any compound. So we are going into the mole whole. We need to divide number of grams by molar mass. Number of gram are given 50 gram, and the molar mass from periodic table of copper sulfate, the molar mass of copper sulfate from periodic table is 159.5. So by calculating, we get result 0.31 moles. So we have find number of moles, and also liter of solution is mentioned. So put the value of number of moles of solute and liter of solution in step number 3. So we have calculated 0.31 mole, and in question we have 2-liter solution. So just put the value 0.31 divided by 2 is equals to 0.155 mole per liter. Okay, the unit of molarity is moles per dm cube, or moles per liter. Okay, making a 1 molar NaCl solution. In lab, we will try this experiment, inshallah. Weigh out and add 1 mole of NaCl in a volumetric flask. You know how to weigh 1 mole of NaCl is simply divide mass in gram divided by molar mass. Like if you take 58.5 gram NaCl And also, you know, molar mass of NaCl is 58.5. So 58.5 divided by 58.5 is equals to 1. So that will be equal to 1 mole. If you take 58.5 gram of sodium chloride, then it is equivalent to 1 mole. Where 58.5 comes from the periodic table. Na, the molar mass of Na is 23 and the molar mass of chlorine is 35.5. So by adding up both the number, we get 58.5. So then add a small amount of solvent to dissolve. First you have to take 58.5 gram or 1 mole of NaCl, and you have to dissolve it in little amount of water. And then you have to take 1 liter flask, okay, and you have to add water unless and until the flask reaches the mark, the water reaches the mark, sorry. Okay, here I will tell you about the lower meniscus and upper meniscus in the lab, inshallah, that what does they mean. But simple is that you have to fill the flask till mark, which is equal to 1 liter. So you have made 1 molar NaCl solution by this way. Now, the second part, what is the molarity of solution made by dissolving 100 gram of NaCl in sufficient water to make 2 liters of solution? Now you have again to calculate molarity of that solution, the 100 gram of NaCl, to make 2 liters of solution. So first of all, you have to calculate number of moles. The formula of number of moles is mass in gram divided by molar mass. Mass in gram is given, that is 100 gram, and we know the molar mass from the periodic table of, we know the molar mass of NaCl from the periodic table, that is 58.5. By dividing these, we get 1.709 mole. So just put in second step, just put the value of moles, value of number of moles in molarity. Okay, 1.709 divided by 2, 2 liter is given in our problem. So the result is 0.854 molar or moles per dm cube. Molarity by dilution. Now, what if we had a solution already prepared, but wanted to decrease the molarity to some lower precise value, like in your lab, the solutions of higher concentration, or the liquids or the acids or the bases are of higher concentration. They are very concentrated. Now you want to dilute, you want to add more and more solvent or add in more and more water to some precise value. और इन सिंपल अगर मैं उर्दू में समझा दूं, लैब में आपके पास इंतहाई कंसंट्रेटेड, स्ट्रॉन्ग या गाढ़े सॉल्यूशन होते हैं या एसिड या बेसिस होते हैं. अगर आप उसको डाइल्यूट करना चाहें या पतला करना चाहें, then what will you do? How could we use an already prepared high molarity solution to accomplish this? Note that it is only possible to go from a more concentrated, means intihai gadha solution, higher molarity solution, to a less concentrated, dilute ya patla solution, having more solvent or having more water. So what would we do? To make something more dilute, we are going to need add more solvent to the solution. So we know the formula of molarity is equals to moles of moles of solute divided by liters of solution. So we need to dilute the solution by adding solvent. But how much more solvent do we need to add? This depends upon the formula. When we add more solvent to a solution, do we change the number of moles of solute in the solution? No. Like, let's suppose your teacher asks to prepare 2 or 3 molar solution from the solution that is available in your lab, in your school lab. But teacher is asking, you have to maintain the molarity. You have to maintain the number of moles present in that solution. Okay, so we just change the number of moles per unit volume of solvent because same number of moles are present, but now there's more liquid. Okay, okay, so we change the number of moles per unit volume of solvent because the same number of moles are present, but now there's more liquid. Let's see how this works. Let's call the molarity of original solution M1. The original solution means that is present in your lab, or the stock solution that you demand from the factory or industry, etc. And the new molarity M2. The number of liters of original solution and the V1 and the new solution will then be designated as V2. So the molarity of old solution is, the stock solution or the original solution is, M1 is equals to moles per liter, and you know the liter is the unit of volume. So you can designate number of moles divided by volume. V1 is divided on the right side, mathematical rules. According to mathematical rule, when it goes towards left of the is equal sign, it will multiplied with M1. So number of moles is equals to M1 multiplied by V1. Similarly, molarity of the new solution is equal to number of moles is equal to M2 multiplied by V2 by the same mathematical rules that are discussed above. Remember that the number of moles doesn't change. When we dilute the solution, the number of moles remain same. Okay, only M1, M2 and V1, V2 are changed. So because moles are equal, so we can cancel the number of moles, and the resulting equation will be M1 V1 is equals to M2 V2. Okay, now let's take a numerical. Remember, I have just derived how to calculate M1 V1 is equals to M2 V2, and I also tell you that in your course there is no derivation, there is no such explanation for the derivation of M1 M2 is equals M1 V1 is equals to M2 V2 formula. Okay, so don't be tense and just note down the formula of dilution. M1 V1 is equals to M2 V2 and solve the problems. Just there is no need to learn about the derivation of the formula. Okay, so how much of a 3 molar solution of nickel chloride is needed to prepare 100 ml of 1.75 molar solution of nickel chloride? So remember, original solution is 3 molar, and we have to calculate that how much of volume would we take from that original 3 molar solution from 3 molar nickel chloride. Okay, or in other words, if a bottle of nickel chloride is present in your lab, in your school lab, then and the molarity of that solution is 3 molar, then how much volume from that bottle of nickel chloride would you take to form 100 ml of 1.75 molar solution? So molarity 1 M1 is equals to 3 molar, M2 is equals to, we have to make 1.75 in zero point 0.1 liter or 100 ml, converting milliliter into liter. So just put the value M1 is equals to 3 multiplied by how much volume would you take from that original bottle or that stock solution, and you have to prepare M2 the new solution, which is 1.75 molarity and having 0.1 volume. So just by calculating, the result becomes 0.058 liter or 58 ml. It's depend upon you whether you take volume in ml or in liter. There is no need to convert ml into liter. Okay, how, there is another example. How do we take how do we make 5 liter of 1.5 ml solution of KCl from 12 molar stock solution? So We know that for stock solution we use M1V1, and for new solution we use M2V2. Okay, so put the value of for the stock solution, and we have to take some volume from the stock solution, and we have to prepare the new solution of molarity 1.5 and volume 5. So by calculating we get 0.625 liter. So you have to add 4.375 liter water to a 0.625 liter of 12 molar solution, or in other words, just take 0.625 liter from the stock solution and dissolve it in little amount of water, and then add water until the 5 liter flask, the water in the 5 liter flask reaches up to the mark. Okay, Allah Hafiz, thank you so much.